When a missile is launched, the question isn't just, can it be intercepted? The real question is, how many can be intercepted simultaneously across multiple fronts? Because a single air defense system under stress is one problem. But when Israel, Gulf states, and US forces activate layered defenses at the same time, you're no longer looking at interception. You're looking at systemic load. And systemic load changes the war. Let's map the architecture. Israel operates a three-layer shield: Iron Dome, short range; David's Sling, medium range; Arrow, long-range ballistic interception. The US deploys THAAD batteries in the Gulf, Patriot systems at bases, Aegis destroyers equipped with SM-2, SM-3, and SM-6 interceptors. The UAE and regional partners operate Patriot and THAAD variants, often integrated with US radar and tracking systems. Individually, each system is capable, but capability is not the same as endurance. Each battery has limits. A Patriot battery can engage only a finite number of simultaneous targets. THAAD has tracking limits. Iron Dome batteries can only launch so many interceptors before reload. Air defense is not infinite firepower. It is controlled allocation. If 20 threats approach one sector, the system can respond comfortably. If 80 approach across 4 sectors within minutes, prioritization begins. And prioritization reveals stress. Now, let's talk numbers. Iron Dome interceptors cost tens of thousands per shot. David's Sling and Arrow cost exponentially more. THAAD interceptors reportedly exceed $10 million per missile. In a 48-hour exchange, a system might fire dozens, even hundreds, of interceptors. That's not just tactical expenditure, that's industrial expenditure. Every interceptor fired must eventually be replaced. Production lines do not scale overnight. Missile factories operate on monthly timelines, not hourly. So when launch rate exceeds production rate, stockpile depth shrinks. That's the hidden timer in modern missile exchanges. Missile defense works in cycles. Engage, expend, reload. Reloading launchers requires time, heavy equipment, and security. Now imagine multiple regions reloading at once. Northern Israel, Central Israel, Gulf bases, naval assets. Reload windows begin overlapping. This is the most dangerous phase, not the first wave. Because during reload, capacity dips. If a second coordinated wave arrives during overlapping reload cycles, interception probability drops. Not because systems fail, but because they are temporarily thinner. Now add another variable. Air defense networks rely on radar tracking and command links. When several nations operate high-powered radar systems in overlapping airspace, the electromagnetic spectrum becomes crowded. Data must be shared. Targets must be deconflicted. Intercept arcs must be coordinated. Misidentification risk increases, latency increases, decision timelines shrink. This is where human command pressure becomes critical. Because even automated systems rely on human authorization at key decision points. Under multi-front stress, decision tempo accelerates, and accelerated tempo increases error risk. US Aegis destroyers in the Gulf or Eastern Mediterranean provide another layer, but naval assets have their own constraints. Magazine depth is limited. Reloading at sea is complex. Repositioning requires time. If naval interceptors are used heavily, those ships must either withdraw to reload or operate with reduced depth. A multi-front scenario forces naval assets to choose coverage zones, and coverage gaps create vulnerability corridors. Resupply is not invisible. Strategic airlift flights, transport aircraft moving interceptors, carrier strike groups repositioning. These are observable indicators. When reinforcement begins, it signals stress recognition. If the US begins accelerating logistical throughput into the Gulf, that suggests burn rate has crossed comfort thresholds. And once logistics become active, escalation becomes harder to reverse. Because supply movement signals long-term engagement. Here's the core insight. Multi-front activation doesn't cause instant collapse. It causes depth erosion. At first, systems perform normally. Then, selective engagement begins. Lower priority targets may not be intercepted. Stockpiles become strategic assets. Political leaders begin asking, How long can we sustain this tempo? That's when deterrence math shifts. Because adversaries watch. They measure response time, reload intervals, engagement discipline. When depth thins, probing increases. If you want to detect real systemic stress, watch for simultaneous launch spikes across separate regions, publicly visible interceptor resupply or emergency production acceleration, policy changes in interception criteria. When those appear together, you're no longer watching isolated exchanges. You're watching structural pressure. And structural pressure is what transforms limited conflict into regional instability. Modern missile defense is resilient, but resilience depends on depth, coordination, and industrial sustainment. When multiple fronts activate at once, the battlefield is no longer just physical. It becomes mathematical, and mathematics decides endurance.